Hi everyone, welcome to our channel AI Kiwi Hub. This is the part 2 video of Create a Question Answering System using Document Retrieval and a Language Model. As I mentioned before, in these 3 parts, I use the docx loader, embeddings, Chroma Database, the max marginal relevance search by vector function, and other relevant functions to achieve the goal. In part 1, we set up an initial document processing and vector database, and an EMB file was created. In part 2, we are going to define a custom retriever class. Let's create a file named redundant-filter-retriever.py. If we have large data, Chroma Database will cost us money, so it's necessary to reduce as many duplicates as possible. So we are going to use max marginal relevance search by vector function in this part. The max marginal relevance search by vector function is a method used in information retrieval and document ranking. It's part of the maximum marginal relevance (MMR) algorithm. It aims to balance between relevance and diversity in search results. It has 2 purposes. First, to retrieve a set of documents that are both relevant to a query and diverse among themselves. Second, it helps reduce redundancy in the search results while maintaining relevance to the original query. I have a habit of taking notes in my code. Those notes could help me in the future and tell me why I wrote such codes. Here my notes are: Chroma can remove duplicates automatically by using the max marginal relevance search by vector function. Let's import relevant libraries first. From LangChain OpenAI, import OpenAI embeddings. From LangChain community.vectorstores, import Chroma. From LangChain.schema, import base retriever. From LangChain.schema.embeddings, import embeddings. Next, uses the Chroma database and embeddings created in main.py, and implements a method to retrieve relevant documents while filtering out redundant information using max marginal relevance. Let's define a class called redundant filter retriever that inherits from base retriever. I have 2 class attributes, embeddings and Chroma. Then define a getRelevantDocuments method. Let me take a query as input. Embed the query using the embeddings object. Uses the Chroma object to perform a maximum marginal relevance search using the embedded query. I set the lambda mult parameter to 0.8. Let me explain what is lambda mult. The lambda mult parameter, often written as lambda in mathematical notation, it's a value between 0 and 1 that determines how much weight to give to relevance versus diversity. It balances between relevance and diversity in the search results. When lambda equals 1, it focuses entirely on relevance, ignoring diversity. This is equivalent to standard retrieval. When lambda equals 0, it focuses entirely on diversity, ignoring relevance to the query. When lambda between 0 and 1, it balances between relevance and diversity. I use the getRelevantDocuments method. It's an asynchronous method that simply returns an empty list. The whole class is to be designed to retrieve relevant documents based on a given query using embeddings and a Chroma vector store. The getRelevantDocuments method is the main functionality, while the async version a getRelevantDocuments are not implemented and just returns an empty list. Okay, my second part of the code has been created. I will not run the code, as it will not print out anything. but I will import this redundant filter retriever file in my third-part code called prompt. I will share my part 3 video later. Hope you enjoyed today's video. Thank you for watching. If you like our videos, please hit the subscribe button and like the video. This will encourage us to create more AI videos in the future. Please leave your comments below, and it will let us know what you want to watch on our channel. Thanks.